Okay, very good. So welcome Tuesday, October 6th, a class session. What we're talking about in these next couple of weeks, we opened up the concept of polynomial last time. Combinations of positive or possibly zero powers of variables. Combinations of numbers times powers of variables. We want to be able to evaluate them and subtract them. That's the sections you worked on this past week. And now, this week, especially multiply and divide them. And other class notes. And I sent you an email over the weekend just to give you a general statement, just to remind you what we were doing. I also told you that I am away at a conference the rest of this week after 2 p.m. today. So today or this week we're meeting in this session, and we're not having any other meeting session or office hours on Wednesday or Thursday. So you can reach me by email, but I may be responding to you after conference hours, after the conference is over for the day. You have a homework that you're submitting tomorrow, a written homework. And then I can remind you about that. And then there'll be another homework posted for you to work on. So you have your ordinary written homeworks and computer homeworks due tomorrow. I'm just trying to remember myself what the written homework is about. We'll look that up for you and remind you. Okay. Any general questions you want to ask or get on the board before we get started? We're in week 6. Remember, there's an exam in week 8 that we've been reminding you about, and we'll be more specific, much more specific about the content of that next week. Just to share screen here to remind you what your homework problem is. 2 questions, and right now you're looking at the homework problem on your screen. In the previous week, we'd been solving systems of equations, 2 equations, 2 unknowns, which in plain English is just where do 2 lines cross? But in this problem, I gave you 2 lines that are not pretty. So I want to see the solution to this system of equations, not just an approximation. I want to see the exact answer to this solution. And then as good a graph as you can make in this graph paper window provided, or you can use your own graph paper. And the problem will not be some happy answer like 2 and 4. X equals 2, y equals 4. Doesn't work. So you have to do this carefully, draw it carefully, but you can make a nice picture of this. You can also check it on your calculator or on Desmos. You have lots of ways to check, but I do not simply want the answer. The answer alone probably gets you 1 out of 10 points. Graph produced by Desmos, 1 point. I want you to draw the graph here. You can certainly use Desmos, your calculator, to check if you drew a good graph. Okay, that's first part. Second part is, here's an example that you would not find in the book. And that is, okay, you guys already know I'm a basketball fan. So, Los Angeles Lakers, Western Conference Finals, they defeated the Denver Nuggets 117-107. And the top 4 scorers for the Lakers were LeBron James, Anthony Davis, Danny Green, and Alex Caruso. So if I describe to you a bunch of silly things like Green and Caruso scored the same number of points, James scored as many points as Green and Davis combined, Davis scored 5 more points than twice Caruso, James and Davis combined for 65 points. I mean, Anthony Davis is, contributing. Could you tell me what all 4 of them scored? So if you have 4 unknowns, you'll write 4 equations from the things I gave you. Literally, there are 4 sentences here in the second paragraph. Can you tell me what each player scored? I know you could go to the newspaper, you go online, and find out what each player scored. And if you like, that'd be a great check. But you could also solve this system. You create 4 equations, 4 unknowns, and you could find out what each player scored. So just trying to make it a little bit fun. I mean, maybe if you're not into basketball, it's not fun as much as I think it is, but just an example. Okay. Remember, on our website, we have some nice Desmos things that'll help you graph 2 lines and find out where they cross. We have some handouts about line equations, handouts about graph paper if you need them. And then let's see what we're doing this week. Oh, excuse me. If you look, it says 5.2 through 5.5. Actually, I moved section 5.5 into next week. So we're just doing sections 5.2, 5.3, and 5.4. I'm going to let you read 5.4 mostly on your own. Okay, back to the paper. So polynomials, evaluate, add, subtract, multiply, divide. Let's just do some quick review because we talked a little bit about polynomials last time, just to warm up. So here's a polynomial. This polynomial says 3x cubed minus 2x squared plus 1x minus 7. It's got 4 terms, just the vocabulary here. Each one of these is called a term. This drawing is going to get pretty littered if I draw arrows everywhere. Each one of the terms has what's called a degree. The degree of a term is the power of the variables being used. Like this term has power of x equal to 3. What exponent do you have? Or sum of exponents you have. So the degree of each term, this term has degree 3, this term has degree 2, this term has degree 1. There's no variable or power here. In that case, you say it has degree 0. This is definitely going to get too busy, but you can print out and look at it. The numbers in front of the variables are called the coefficients. Here the coefficient, the number in front of x cubed is 3. Here the coefficient is minus 2. The number and the sign belong together. Here the coefficient, it's unwritten, but it's a 1. 1 times x. And here the coefficient, the number in front of the x, the variable, you say there is no x. Yes, but I say, well, the coefficient is just the number in that term, minus 7. So these are called the coefficients. I guess I'm really going overboard. If I'm going to litter it, I'm going to litter the whole paper. Okay. One more term. Let's do this in purple. The degree of the polynomial in general. Now remember, we had words for how many terms there were. 1 term. That's called a monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. 4 terms, we don't call it a quadrinomial. Let's just call it a polynomial. So degree is how many powers are you using in that term? 3, 2, 1, and 0 powers. But when someone asks you for the degree of the polynomial, what they want is the highest degree. The highest degree among all of its terms. So they want the winner, so to speak. The degree of this polynomial, this whole polynomial, is the last arrow I'll write on the paper, I promise, is 3. Because among the 4 pieces, the highest degree was 3. Now, polynomials can have more than one variable, right? So let me try something else, just so you can make sure you're flexible. Let's say I had 2 variables. I can have as many variables as I want, as long as I only use positive powers of the variables. Positive integer powers. Minus 7xy cubed minus 3x. So let's run through the vocabulary. This is a trinomial. You can call it polynomial, but it's got 3 pieces. So we call it often a trinomial. It's got variables x and y. The degree of each term is the powers I use in there. Now, I want the sum of the powers. This is power 2, power 3. The degree of this term is 5. The degree of this term, 3 and 1. There's a 1 power of x right there. Degree 4. The degree of this term, there's only 1 power of x. Total of the exponents used here is 1. Total exponents here, 4. Total of the exponents here, 5. So this is a trinomial, 3 terms, degree 5, degree 4, degree 1. So who's the winner? The 5. If someone asked me for the degree of this trinomial, I would say it's a trinomial of degree 5. The coefficients are just the numbers in front of the variables. Coefficient 3, coefficient minus 7, coefficient minus 3. Those are the 3 coefficients. Any other terms I used here? Nope. It's a trinomial. Some people say in x and y of degree 5 with coefficients of 3, minus 7, and minus 3. When we write polynomials, it is a common convention, but not a requirement, but it's very common to write the term with the highest degree first and down the line. So write it from most degree to least degree, 5, 4, 1. Not a requirement, but often used that way. Evaluating. Let's go back to this polynomial right here. 3x cubed minus 2x squared plus x minus 7. If someone told you to evaluate that, x equals minus 2, it just means put minus 2 in for every x you see. But you have to do that very carefully, very honestly. And it's easy to make a mistake with a sign. When I put a -2 in for every x I see, what I get is 3 times -8. -2 times -2 times -2 is -8. -2 times +4. -2 times -2 is +4. -2 minus 7. What is that? -24, -8, -2, -7. I didn't plan it that way, but I got all negatives. So it's going to add up to -10, -34, 7 down, more, -41. That's called evaluating a polynomial. If the polynomial has 2 variables, you can evaluate that if someone gives you 2 numbers to plug in. 3x squared minus y cubed minus 7xy cubed minus 3x. What if someone told you to evaluate this? At, or they could say when. X is -1 and y is 2. They literally mean, and you should do this, they literally mean insert those 2 numbers for every x and y you see. Do it with parentheses just to protect yourself. You don't need to use separate colors, but make sure you put the 1 negative in the x place only. Make sure you put the 2 positive only in the y position. And remember, I was supposed to cube that y. And then just work out this number carefully. 3, -1 times -1 is 1. 2 times 2 times 2 is 8. -7, -1. Again, 2 times 2 times 2 is 8. And now -3 times -1 is +3. Keep simplifying. 3 times 8 is 24. Sometimes you think of numbers and signs differently, right? -7 times -1. It's going to be positive. +8, positive. The result here is positive. What's the number? 7 times 1 times 8, 56. And then I'm going to add 3 more. When I'm done, I get 24 and 56 plus 3. That is 83. Okay, that's what people mean by evaluating. Evaluating means insert a number for the variable or variables. Add, subtract. We mentioned this last time, but we didn't give much of an example. The magic words are combine like terms. And so when you add and subtract, you only combine pieces that are exactly the same. For example, if I had 3x cubed minus 2x plus 7, and I was adding that to -5x cubed minus 3x squared plus 7x plus 1, then I add the x cubes. I add the x pieces, I add the constants, but this x squared, there's nobody to add it to over here. That's fine. No x squareds minus 3x squareds would be minus 3x squared. Cross them out as you go. 3x cubes minus 5x cubes, -2x cubes. Let's write in order. Got some x squareds here, but the total, none plus -3. -3x squareds. Got some x's. I cross them out as I go. That's just a habit. Sorry, I have to move the paper up. Oh, okay, good question from Jacob. Let me answer that. The answer, how to interpret sentences, the answer is no, you've got to practice it. Although in the book, in some of the word problem sections, they walk you through interpreting the word problem sections, and there are videos in the book. So they've got to be scattered in the application videos. They say, this is how you interpret that. This is how you interpret that. That takes a lot of practice. But you have to say to yourself, and remember you asked me the question last time when we were reading something like, this is twice that. You have to say to yourself, did I put the two in the right place? Let me test it. That's a really good question, Jacob. But he has, and his partners, the different people that do the videos, they'll talk to you about things like that as you're doing them, but not specifically a video only for interpreting. They want you to learn by doing that directly. I didn't mean to interrupt my thought, but it was a really good question. Okay, got my x cubes, check. Got my x squareds, check. How about -2x plus +7x? That net result is +5x. Lastly, got my constants. 7 plus 1, +7 plus +1, +8. Now subtracting them would be similar, except I'd have to use minus sign correctly, right? So how to practice that? I'll just pull one out of the book right here. And why don't we just go crazy? Let's look at 27 right there. How do you feel about fractions? Really, really annoyed. Whenever I see a fraction, I want to run away. But they're just numbers, so I got to practice adding those numbers. I'm subtracting, right? So everybody in the second bracket is going to subtract 1x squared, subtract -2/7xy, subtract -9/4 y squared, -9/14. So let's do a subtraction problem that's ugly. This is section 5.1, number 27. 4/7 x squared minus 1/7 xy plus 1/14 y squared. And then subtract this person, 1/2 x squared minus 2/7 xy minus 9/14 y squared. I do see what things belong together, right? That's not too bad. Got some x squareds, got some xy's, got some y squareds. They left them in order for me. They're even nicer, right? But the trick is, do I subtract properly? So let's put them together. 4/7 x squared minus 1/2 x squared. Then minus 1/7 xy minus negative, which means plus 2/7 xy. In the last position, positive 1/14 y squared minus negative, which means plus. You subtract negative, you're adding plus 9/14 y squared. So I put them together just so I could look at them for a moment. The last two are not bad. 1/14 and 9/14 is 10/14 y squared. Now you're obligated to make things as simple as you can. 10/14 is 5/7. Okay, that's done. What about right here? xy minus 1/7 plus 2/7 total positive 1/7 xy. And it can't be simpler than that. So that's done. The one here that's going to cost me a moment is the x squareds, because I have different denominators. Okay, I just have to manage it. Common denominator would be 14. And 4/7 is the same as 8/14 if you multiply top and bottom by 2. 1/2 is the same as 7/14, 1/2, 7/14 if you multiply top and bottom by 7. Now I can subtract since they have common denominator. 8/14 minus 7/14, that's 1/14 x squared. Now you don't need to present a multicolored answer, so let me just write them more neatly together. That's what I get when I subtract those two polynomials. What's the degree of each one? Degree 2, degree 2, degree 2. This polynomial is degree 2. This polynomial is also degree 2. Each piece has degree 2. When you say x times y, you're using 2 powers, x to the first, y to the first. So these are both polynomials of degree 2. They got the funny coefficients, x and y. So that's how you subtract stuff, even if they're not friendly. Look at 36 just for a second. Not because it's long, but because I want to get used to the language. Find the difference of 2x squared. Oh, okay, this is number 35 I'm writing down. Minus 7x and 2x squared minus 4x. When someone says the difference, they mean subtract. And this is an awkward way to say subtracting, though, because if someone says, find the difference of 7 and 3, do you say 7 minus 3 or 3 minus 7? So I'm going to look for someplace in the book where they actually make you do it like that. Pick out this example here. Sorry, jostling my camera. Example 4 in the book. Find the difference of this polynomial and that polynomial. So we subtract by adding the opposite of each term in the polynomial that follows the subtraction sign. So they're taking the one you subtract to be the later one. So I'll do that too. Except I don't like it when someone says find the difference and they don't tell you which order to use. But you can adjust to their method. They want 2x squared minus 7x, subtract 2x squared minus 4x. You could literally rewrite 2x squared minus 7x, subtract 2x squared, subtract minus 4x means plus 4x. And then 2x squareds add up to nothing. They're not even there anymore. Minus 7x plus 4x minus 3x. So if you subtract them in the correct order, they want you to say minus 3x there. Okay. Back to the top, just to keep you focused on where we are.
Could you move your other paper like down or up a little bit?
That one, yes, thank you.
Thank you.
That's that I didn't see that. Thank you. So let me say that again quickly. When someone says find the difference in this book, they want you to take the first one minus the second one. I write it with a minus. Then I just kind of apply that minus to both pieces. Honestly, you got to apply the minus to all of them. You have to subtract all these people. And I combine like terms, and I got to break. No more x squareds. Negative 7x plus 4x, negative 3x. Okay. Thank you for reminding me. So those things are a little bit, not messy. Maybe the words are fancy, but to evaluate just means to insert the number carefully. Yes, you have to watch your minus signs. You have to multiply and add things correctly, sure. Adding and subtracting doesn't always bother people as long as they remember that they only add things that match exactly. Don't say 2x cubes and 4x squareds is 6 somethings. That's like saying 2 apples and 4 oranges is 6. Okay, 6 pieces of fruit, right? But we're not going to do that with polynomials. They're just 2 apples and 4 oranges. This is the real thing I want you to focus on today. And I'm going to show you multiple ways to do this. How do you multiply and divide? What is the magic word? Any Harry Potter fans in the audience? And all the kids that like Harry Potter when you're growing up, and sure, I've read the books just with my kids. I've watched the movies with my kids many times. And they got all these goofy spell names, and kids are excited to repeat the language from the movies and name the spells. Okay, combine like terms. That's not a spell, but it's an instruction. It's kind of like a spell. That's the instructions for adding, subtracting, combine like terms. Likewise, multiply and divide. Multiplying and dividing is a little more work, but I can give you the magic word. And then if you remember that magic word, then you remember the plan for multiplying and even dividing. The word works for both. And the word is distribute. When you multiply or divide, the magic word is distribute. Now, what makes multiplying and dividing polynomials busy, what makes people not like it, is because the problems can be really small and, oh, that's no big deal. Or they can be really messy, where you got lots of things to keep track of once. And I'll show you how to do it either way. But I want you to think that the common theme through all the multiplying and dividing problems, whether they're short, easy, long, messy, the common theme is always that word distribute. So I'll try to keep emphasizing that word over and over as I show you how to distribute. Okay, let's build. I'll show you some really slick ways to multiply and divide too. But let's build from basic. Multiply means distribute in this sense. 3 times 6 is 18. And you never think about it this way. You don't necessarily think about it this way, but you could think about 3 times 6 ones. I shouldn't have picked 6. Each one of those ones gets tripled. 3 times 1, 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 3 times 1. Each one of those 3s gets tripled. You're just adding together 3 6 times. This is not a very exciting example. You already know it's 18. But distributing works whether you're thinking about numbers or variables. If I say 3 times x plus 2, distribute is still the magic word. Distribute means, just like you wanted 3 copies of each one, I want 3 copies of x and 3 copies of 2. 3 copies of x is 3x. 3 copies of 2 is 6. But you probably do that kind of automatically, not even thinking about it, but think like that. Just every time you multiply, say distribute to yourself. Even if it's all variables, here I'm going to multiply x times x squared y minus xz. It's still distribute. Let me write it out. X times x squared y minus x times xz. But you don't stop when you can make things simpler. If I have 1x times x times x, I mean, literally x squared is x times x. I have 3 x's multiplied together. That's what I call x cubed. Here I have subtract x times x. That's what I call x squared. So usually I do this without writing down this middle step. I just say, oh, that's x cubed y minus x squared z. So letters or variables, I'm sorry, letters, x, y, z, letters or numbers, variables or numbers, the word is always distribute. Now let me pump it up. And you've seen this before, possibly, but I still want to emphasize this word distribute. Let me multiply these 2 people on the left times these 2 people on the right. Some people like to remember this word, FOIL. Multiply the first 2 pieces, multiply the outside pieces, multiply the inside pieces, and then multiply the last pieces. I don't have any problem if you like saying FOIL, except if I have more pieces in here, then you got to pick up a bigger word, right? So use FOIL if you like to say, oh, I'll foil it. It's like a verb now. Let's foil it. But think about distribute as a verb. Let's distribute. Let's take 3x times both of these people and 2 times both of these people. Then I'll have taken everyone in the first polynomial times everyone in the second. 3x times 2 is 6x. I like to cross them out as I go. 3x times minus 7x would be minus 21x squared. 2 positive 2 times positive 2 would be plus 4. Positive 2 times minus 7x would be minus 14x. I'm not done till I clean it up because I do see that these two people, 6x minus 14x, can be combined. I do also want to put things in order from highest power to lowest. So final answer here would be 21x squared negative. Then 6x minus 14x is negative 8x. And then this constant 4 was by itself. There was nothing else to combine, plus 4. So multiply means distribute. Now I want to do a harder multiply problem now. Let's say you had to multiply 2x squared minus 3x plus 7, and you had to multiply that by 4x minus 3. This is not too much harder, but I want to illustrate a different way of writing it. I want to illustrate 2 different ways of writing it in a way. Some people like to write it in different ways. I'm going to show you different ways to write it. You pick the one you like. As long as you do it correctly, I don't mind which method you use. FOIL doesn't cut it anymore because really I have 3 people times 2 people. And I could go and do the arrow thing, right? Nah, 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 nah. But it's too many arrows. I don't like that. You say, well, it's because you drew your arrows in the wrong place. What if I just did my arrows like this and then like that? Okay, sure. Now I got all 6 arrows in there. 6 connections, 6 products. But that's just a royal pain to, I don't want to litter my paper with marks every time to make sure I'm doing it correctly, right? You could be the person who likes to cross things out as you go. Except I really don't want you to cross things out. When I say that, sometimes I mean I underline them. So I want to make sure I do 2x squared times everybody. 2x squared times 4x is 8x cubed. Now 2x squared times minus 3 is minus 6x squared. Now I'm done with the 2x squared. I've used it twice. I'm not done with these others. Minus 3x times 4x is minus 12x squared. Minus 3x times minus 3 is plus 9x. Now, I'm done with the minus 3x. Finally, positive 7 times positive 4x is positive 28x. Positive 7, I use the 4x. The third time I use the 4x. Positive 7 times minus 3 is minus 21. That's the third time I use the minus 3. I think this is a little cryptic too. Did I use each of these people twice? Yes, I did. Did I use each of these people 3 times? Yes, I did. that's just the way I like to write it sometimes. I'll combine the answer now. 8x cubed minus 18x squared plus 37x minus 21. You could have got the same answer if you would have used the arrow things. Let me show you one other way to write it that sometimes people find useful. Same problem. I'm going to take the 2x squared minus 3x plus 7 sometimes people do this, and you can even do this with numbers, is kind of multiply things in a box. So if I wrote 2x squared minus 3x plus 7 on the top side of this box, write 4x minus 3 on the left side of the box, I could say I am multiplying everyone on the left times everyone on the top and put the answers in these boxes. Now I could draw little box lines. I'm not going to draw little box lines, but let's just go through it. It's just another way of making sure you multiply everyone, right? So what I got here is 8x cubed. 4x times that minus 12x squared. 4x times 7 plus 28x. Now let's do minus 3 times everybody. But minus 3 times 2x squared is minus 6x squared. I don't want to put it in this x cubed thing because I want to add straight down, right? How about minus 3 times 2x squared? Let's put it over here. Minus 6x squared. Minus 3 times minus 3x. Let's make it plus 9x. This is kind of the x cubed column, the x squared column, the x column. Finally, minus 3 times plus 7 is minus 21. So I have 8x cubed minus 18x squareds plus 37x's minus 21. That is the exact same answer I had a second ago. This is not new or better. Exact same answer. But some people like to organize things in a box like this. If you can tolerate one more method, sometimes people do it like this. 119 times 47 is 7 times 9 is 3, carry the 6. 7 times 1 is 7, plus 6 is 13, carry the 1. 7 times 1 is 7, plus 1 is 8. 4 times 9, 6, carry the 3. 4 times 1 plus 3 is 7, no carry. 4 times that is 4. Now I add 3, 9, 5, carry the 1. 19 times 47 is 5,593. You can multiply polynomials the same way, if that's what you like to do. Let's write them in their columns. And multiply. Negative 3 times negative 7 is negative 21. Negative 3 times negative 3x is positive 9x. Negative 3 times positive 2 is negative 6x squared. 4x times 7 is 28x. It belongs in the x column, just like these numbers belong to the ones, tens, hundreds, and thousands column. 4x times minus 3x would be minus 12x squared. 4x finally times 8x, 2x squared is 8x cubed. And it doesn't do anything different. It's got to be the same answer because I can't change the answer by using a different method, or else I must have made a mistake. I don't know which way you've seen it multiplied. Oh, sometimes use a little asterisk for multiplying, because if I use an x for multiplying, like 7 times 3 is 21, then sometimes people interpret that as a variable x. Okay. Asterisk, some people use a dot. I don't mind what you use as long as you do it consistently. How do I multiply things? Mostly myself. I guess if I had my way, I'm foiling, I'm stacking them on each other and crossing them out. Sometimes the fancy larger problems, I do this box method. I like this box method. It's up to you which one you want to use. But I want you to acknowledge that every time the magic word was distribute, or if you want me to say it more casually, everyone times everyone I should be more careful. Everyone in the first polynomial times everyone in the second polynomial. I shouldn't be too casual when I say things because then people can interpret it in multiple ways. Okay. Maybe you've multiplied a lot of polynomials in your life. Maybe not. Maybe you just multiplied polynomials in algebra class. People kind of accept multiplying a little bit easier than dividing. But if I can make you focus on this word, I can show you how to divide really well. Dividing polynomials really well. And dividing polynomials is sometimes the thing that most sticks on people, most grates on people, makes people most uncomfortable. So I want to emphasize this word distributing. Now, we're at the top of the hour, so I'm not in any particular hurry. So why don't we take a break? Let's come back. I got 56 on my watch, 57. Let's come back at 102. And I'll show you how to divide as fast as you can multiply. Multiplying is not super fast. A lot of things to add together, but you got a plan. I'll show you how to divide with a plan. And then you can do that fast too. Stretch your legs. I'm going to just mute my microphone while I stretch my legs myself and come back in about 5 minutes. Okay, we're back. Is dividing distributing? I mean, in a very real way, dividing is distributing. I showed you these different methods for multiplying, stacking the terms in columns, the box method, other things like that, just so that you can see. Now, as I show you how to divide, I'll show you how to use things that look like that too. You've done dividing before. You've done dividing of numbers before. Maybe you've even done dividing of polynomials before. But somehow there's so many moving pieces. People think that that's a little bit harder, more distracting. But first of all, dividing is distributing. So I just want to reinforce that. It's also distributing in a way. In fact, sometimes you use that word literally. It's Halloween candy time, and got this bag of 36 Snickers bars. I don't know how many trick-or-treaters I'm going to have this year, of course. I don't know how many kids are going around. Oh, COVID-19 and everything, but let's just say 4 kids come to my door and that's it. And I got to get rid of those 36 Snickers bars or I'm in serious trouble. Well, you literally, when you say 36 divided by 4 is 9, you're thinking of dividing 36 into 4 equal pieces. So when you got to distribute candy on Halloween, it's literally you're dividing the candy among the kids that come to the door. Of course, you could also think of 36 as 9 piles of 4. Now, I guess I didn't like that or plan that well because 9 piles of 4 is going to take a lot of writing and almost go off the paper. So I apologize if that's too hard to read, but I meant that to be 9 piles of 4. Now, there's nothing to stop you from dividing 37 candy bars into 4 piles. And the most likely way you would do that is say, well, the first time you learn to divide, well, it's 9 with a remainder of 1. Remainder is just a fancy word for what's left over. So 4 kids came to my door. I gave them 9 Snicker bars each. Kind of generous at Halloween. That way I get rid of the candy faster and just can relax. But there's 1 Snicker bar left over. I guess I'll have to eat it. Or sometimes you could say like this, there's 9 1/9. And that literally means 9 and a remainder of 1. Sorry, 9 1/4. A remainder of 1 upon division by 4. That's what someone says when they write 9 1/4. In fact, they don't even write 9 plus 1/4. Over time, people stopped writing the little plus sign in there. They just call it 9 1/4, 2 1/4 cups of flour, 9 1/4 Snicker bars. If I was allowed to cut Snicker bars into 4 pieces because I don't want to eat that leftover Snicker bar. and distribute 1/4, 9 1/4 Snicker bars to each kid. Now, is it the same with polynomials? And the answer is yes, it's exactly the same. Sometimes the numbers don't come out as sweet. Because if I had 36x's plus 12, and I told you to divide by 4, you would do the most natural thing possible. You would try to divide each by 4. And in this case, that works out very sweetly. 36x's divided by 4 is 9x's, just like 36 divided by 4 is 9. And then 12 divided by 4 is also perfect. 12 divided by 4 is 3. So when you say 36x plus 12 divided by 4 is 9x plus 3, what you're really saying is that 4 times 9x plus 3 is 36. If you put them all back together again by multiplying both sides by 4, I'm sorry, 36 plus 12, 36x plus 12. I made a mess out of that. If you multiply them back together, you get what you started with, 36x plus 12. So since multiplying is distributing, dividing is distributing too. Now, sometimes things don't go in evenly. And so if someone said, let's divide 36x plus 13 by 4, I would have no problem if 36 went in perfectly, 4 went in perfectly there, and 4 didn't go into 13. I could say it's 9x. And here I could say it's 3 1/4. That would be 13 divided by 4. 13 divided by 4 is 3 1/4. But it looks a little awkward to say 3 1/4, like I'm mixing two different kinds of numbers. So really, when people do this, they just write 13 over 4. Leave it like that. And this is how you do fractions in general, right? You have many opportunities for fractions. Let's talk about 9/4. Now that is the same as 2 1/4. And it's also the same as 2.25. These are all exactly the same. But sometimes I prefer to write 9/4. Sometimes I prefer to write 2 1/4. Sometimes I prefer to write 2.25. Oh, I was going to pull up the Toll House cookie recipe. And I don't have a good bag of Toll House cookies. I mean, anybody know your Nestle Toll House cookie recipe? You know, chocolate chip cookies? How many cups of flour do you use in the Nestle Toll House chocolate chip cookie recipe? 2 1/4. They don't write on the package, use 2.25 cups of flour. They do not write on the package, use 9/4 cups of flour. They write 2 1/4 because that's an easy way for measuring. Likewise, if I say Miguel Cabrera was hitting 351 in a particular season, it's not this season. In baseball terms, that means he gets 351 hits every 1,000 times he goes to bat. Now, baseball, they even print this as 0.351. They don't put the 0 in front. If you look at the batting average on the TV or in the newspaper, it'll say 0.351. That means 351 times out of 1,000, he gets a hit. That's the rate at which he gets a hit. When he ran the Triple Crown, he was hitting in the 350s, I think, when the Tigers first picked him up from Texas or wherever. I forgot where. You commonly say he's batting 351, but it's .351. But no one says Miguel Cabrera is batting .351. No, it's .351. They just say baseball slang 351. So you can express 13 quarters as 3.25, as 3 1/4, or just as 13 quarters. Frankly, most of the time, the most flexible one is just to leave it as it is. Now, if you have 18 quarters, you're not supposed to leave that as it is. You always reduce when you can, right? 2 times 9, 2 times 2. Let's cancel it 2. Never say 18 quarters. Simplify it down to 9 halves. But this is called, it's funny the way people name things. This is called an improper fraction. If you've ever heard the formal name. Improper because it looks awkward to have the top bigger than the bottom. Usually you think this fraction is a part of a whole. Like I want 1/3 of a pizza. Or I ate a quarter of the pie. You can never say I ate 9 quarters of the pie because there's only one pie. Now, if there were 3 pies, you could eat 2 1/4 pies. I understand that. But if there's only one pie, you can't eat more than 4 quarters of it. People call this a mixed fraction. And people call this just a decimal. But a decimal is just an abbreviation for a fraction. 2.2 means 2 2/10. 3.21 means 3 21 100ths. 1.316 means 1 316 thousandths. So a decimal is just a shorthand for a fraction. Okay, so there's a little side track. What happens if something doesn't go in evenly? You don't sweat it. I mean, just like 37 divided by 4 is 9 with a remainder 1. You just tell people what's left over. Now, what do we have to do to take that to the next level? What happens if I'm not multiplying by 1 term, but I'm multiplying by 2 terms? Dividing by 2 terms, excuse me. I mean, if I'm dividing by 1 term, I can just divide everybody by that person. But if I'm dividing by 2 terms, let's say 3x squared minus 7x plus 4. It's true that I could divide each of the people on top by x plus 2. The question is, does that do anything useful for me? Maybe. In some cases, it does. But as far as making things simpler, this is not really the road to go, because I used to have 1 fraction, now I got 3 fractions. Is there any canceling that can happen? Any common factors? No, no, no. You can't cancel part of a top and bottom. You can't say, oh, I'll cancel the x. minus 7x over x plus 2. Now you can only cancel factors. So there's no canceling that you can do here. Only can cancel factors. Factors are things you're multiplying together, not adding or subtracting together. So how do you divide 3x squared minus 7x plus 4 by x plus 2? Well, I use an old technique that you probably haven't used. I don't know, you use this 4th or 5th grade when you first learned how to divide and make fractions. You can use an old technique called long division. For example, what's 119 divided by 17? You think about it for a second. I don't think 17 goes in there evenly. You learned one day to do long division, which is, right, 17 go into 119. And you just slowly work it. Does 17 fit into 1? No, it doesn't. Does 17 fit into 11? No, it doesn't. Does 17 fit into 119? Well, it certainly does, but you got to think about how many times. 8 times 80 and 56, 136, too much. 7 times 70 and 49. Oh my goodness. Is 7 times 17, 119? Let's multiply and see. How do we multiply? We distribute. 7 times 7 is 49. That's 9. Carry the 4. 7 times 1 is 7 plus 4 is 1. Oh my goodness. I wasn't even thinking. 119 divided by 17 is 7. And there is no remainder. So that wasn't a very good example. Let's try something else. How about 2,127 divided by 13? But that goes in evenly. I'm going to eat this paper. And I should be really careful when I say something like that, because then I might have to do it. Okay, long division, practice again. 13 go into 2. No, it doesn't. Does 13 go into 21? Yes, it does. And it's not hard to see how many times. It goes in 1 time. 2 times 13 is 26. It goes in 1 time, so I put a 1 in that column. Then I multiply 1 times 13. I distribute. And then after I've done 21 minus 13, I have a smaller number, 827. And I keep doing this. It's called long division. How many times is 13 to go into 8? No, not at all. How many times does 13 go into 82? Well, certainly 13 goes into 82. 6 times? 6 times 13 is 78. That's probably as close as I can get. Put a 6 right here. And distribute. 78. 6 times 13 is 78. And then what do I do? At each stage, I always subtract. And then we got 47. Does 17 go into 4? No. Does 17 go into 47? Yes. 4 times, too many. 3 times would be 39. What does that leave over? 8. So what did I just discover? 2,127 divided by 13 is 163 plus a remainder of 8 upon division by 13. 163 and 8/13. If you wanted to say it with a mixed fraction. 163 and 8/13. Do I want to know if I'm right? Let's take 163 times 13. 9, 8, 1, 4, 3, 6, 1. Add 9, 1, 1, 2. I get 2,119. I don't get 2,127. Why not? Because I had to multiply 163 by 13 and then add the 8 that was left over. 2,127. It worked. Okay, this is called long division. Now I'm going to do it with polynomials. That always drives people nuts. So I'm going to do it with polynomials and show you some shortcuts for doing it with polynomials. So let's take that same problem, 3x squared minus 7x plus 4. And let's not think of breaking it into pieces because that didn't get me anywhere. Let's think of long division. How many times does x plus 2 go into 3x squared minus 7x plus 4? Now, in some ways, this is both harder and easier than regular long division. Harder because there's something you naturally do with numbers that you don't naturally do with polynomials. Easier because it's easier to fit polynomials inside each other. Look at it this way. How many times does x plus 2 go into here? Don't ask that question. Ask the question, how many times does x go into 3x squared? What happens if you divide 3x squared by x? You just get 3x. So in the x column, let's write 3x times x. Give me a 3x squared. Now let's distribute. Let's write 3x times positive 2. Give me a plus 6x. And that's how I can fit x plus 2 in here so that I can subtract and get a smaller polynomial. Here's the thing that people screw up on. They forget to subtract properly. So when you did long division, each time here you were subtracting. Subtract, subtract, even the last time, subtract. I didn't write it, but subtract, subtract, subtract. Long division is always subtract. So when I subtract now.
Could you go over that first part one more time?
Can you say that again?
Can you go over that first part one more time, how you got the 3x?
Good. And we will do it, and we will do it with multiple problems. I'm thinking, how many times can I squeeze? Let's think right here. How many times can I squeeze 13 into 2? No times. How many times can I squeeze 13 into 21? And I said once, and I put the 1 in that column. Now let's do it with the x. How many times, this is casual language, I understand, but how many times can you squeeze x into 3x squared? In other words, what do you multiply x by to get 3x squared? And your choice is you multiply by 3x. 3x times x is 3x squared. And since you multiply by 3x, you put 3x in the x column. But then you have to finish the job by distributing. 3x times x is 3x squared, check. 3x times positive 2 is positive 6x, check. That's the same thing I did when I said 1 times 1 is 1, 1 times 3 is 3, 1 times 13 is 13. 6 times 13 is 78. It's the same thing I was doing before. I decide how many times I can stuff x plus 2 into this. And then we'll do it again. So good question. We'll repeat the process. Now the problem is most people screw up the subtraction, and myself included. Let's subtract 3x squared minus 3x squared. Mostly people do that right. You know, anything minus itself means you got nothing left. 3x squared minus 3x squared, no x squareds left. But what's negative 7x minus 6x? There's a strong tendency to just read these and say minus x, right? But that's not subtracting. What's negative 7x? Subtract 6x minus 13x. How about plus 4? Subtract nothing. Well, that's not so bad. Plus 4. Let's keep going. I have this x here. I want to stuff it into 13x negative. How many times? What do I multiply so that I can get a negative 13x here and make this go away? So I'll multiply this by negative 13. It's a constant. I'll put it in the constant column. And that's perfectly good, as long as I fairly multiply both people, as long as I distribute. Minus 13 times x, minus 13x, minus 13 times 2, minus 26. Oh, I wanted to make that red. And that's not going to help if I just write red over blue. Sorry. Now I want to make that black. That's the problem with multiple colors. Okay, hopefully the multiple colors haven't screwed up your vision. Can you subtract? Can you subtract correctly minus 13x minus negative 13x? Well, again, anything minus itself is 0. But what's 4 minus negative 26? Don't just say 4 minus 26. That's not a 26. That's a negative 26. 4 minus negative 26 is 30. So what you have is this 30 left over. You can't put any more x's in here. There are no more x's. What I have, this is the remainder, is that I've finished the dividing. 3x squared minus 7x plus 4 is equal, divided by x plus 2, 3x squared minus 7x plus 4 divided by x plus 2 is 3x minus 13 plus a remainder of 30 upon division by x plus 2. Just like you say, 9/4 is 2 plus a remainder of 1 upon division by 4. It's the same language, except here you're using polynomials, and here you're using numbers. Now, I'm going to show you another long division. Just get to practice him. And then I'm going to show you a faster way to do it. Over on my whiteboard. Let's do another example. How about x squared minus 7x plus 5 divided by x plus 1. So how many times does x plus 1 go into x squared minus 7x plus 5? How many times does x go into x squared? What do you multiply x by to get x squared? You multiply a single x. X times x is x squared. Is that all you're doing? No, you have to distribute. X times positive 1 is positive x. Can you subtract and not screw up? You got to concentrate. X squared minus x squared, that's not bad. Nothing. What's negative 7x minus 1x? Negative 8x. Do not add these and say minus 6x. You are subtracting. If you have to write the word subtract over here on the left every time you do it, then do that. What's 5 minus nothing? Plus 5. Okay, can you fit another x in here? Sure, I can multiply by minus 8. And that'll make negative 8x's, but also minus 8. So I can fit x plus 1 in here again. Negative 8 times. As long as I subtract correctly, I'm okay. Negative 8x minus negative 8x is 0 x's. When I subtract negative 8x minus negative 8x, I'm really doing negative 8x plus 8x. Changing that sign. As long as I change the sign all the way through. The book does it by writing little change signs up here in the upper corner. I think that's better than changing the signs here because you'll just confuse yourself. But if you just learn to subtract, that's best. This minus this is 0. This minus this is what? For the $100, what's 5 minus negative 8? I haven't offered you guys money for a long time. I've also never given you any money. You could be very sore about. You are correct, Benito, 13. But I just use that analogy of giving you money to make you focus. I'm not saying you're driven by money. I'm just saying if someone lays some money down, then you've got some concentration. 5 minus negative 8 is 13. So now I know the answer to my question. How many times does x plus 1 go into x squared minus 7x plus 5? It goes in 8 minus x minus 8 plus 13 upon division by x plus 1. I want you to notice what this says, just like when we did the dividing by 13. Let's look at this written out really neatly. If I multiply both sides by x plus 1, this side turns into x squared minus 7x plus 5. This side will turn into x minus 8 times x plus 1. And this piece will turn into 13. Because if I do 13 divided by x plus 1, and then I multiply x plus 1 right next to it, I just cancel out the x plus 1s. So the way to tell if I'm right is to multiply. FOIL, if you want to use the word FOIL, distribute. And see if I get the two sides equal. And if I don't get the two sides equal, then I screwed up. Sorry, gotta move my paper up. So multiply both sides by x plus 1, and I have no more fractions. Is this truly x squared minus 7x plus 5? And the answer is x times x is x squared. Minus 8x plus 1x is minus 7x, yes. Minus 8 times positive 1 is minus 8. And then I add 13, and I get x squared minus 7x plus 5. So I am comfortable. I did do it right. Now, there is a funny consequence of synthetic division of division that I want to show you. And then if you think about it in that way, there's a very cool shortcut you may or may not have heard of called synthetic division. It helps you divide polynomials easier. So I want to show you a connection maybe you hadn't considered before. And that is, let's go back to evaluating. Let's look at x squared minus 7x plus 5. What if I told you to evaluate that at x equals minus 1? That's the way we began the day. Watch what happens. You put in a minus 1 for every x. And you be honest about these signs. Just be very careful about these signs. -1 times -1 is +1. -7 times -1 is +7. And you add 5. What's 1 plus 7 plus 5? 13. Well, that's odd. 13 was my remainder. Is that a coincidence? Let's try this other problem. 3x squared minus 7x plus 4. What happens if I plug in -2? I'll show you why I'm choosing -2 in a second. But what happens if you evaluate that at -2? We put the -2 in very carefully. You obey the signs. It's very careful. 3 times 4. -2 times -2 is 4. Sorry, I'll slide up the paper. -7 times -2 is also plus 14 plus 4. And 3 times 4 is 12 plus 14 plus 4. And what does that equal? 26 and 4 is 30. That was the remainder when I did the division. Now that's happened twice, that the number I plug in gives me the remainder. And now something happens to me twice. Then I'm going to do a double take. Something happens to me twice, I start to wonder, 3 times, whatever, until it hits me over the head. I start to wonder if that's a coincidence or if that's always true. So let me write this again. X squared minus 7x plus 5, when I divided it, was x minus 8 plus 13 over x minus plus 1. That's how I did this long division. And then I said multiply both sides by x plus 1. So I got x squared minus 7x plus 5 equals x minus 8, x plus 1, and 13 left over. That's the remainder. Now, let me show you where the magic is. If you evaluate both sides at x equals -1, what happens? It's like plugging into -1 on the left side, and you think of that as a chore. You think of that as a mess. But what happens on the right side when you put -1 into the right side? -8 minus 1 minus 8 is minus 9, but minus 1 plus 1 is automatically 0. Minus 1 plus 1 is automatically 0. And that just leaves what? 13. If I divide by x plus 1, in some ways, the remainder is what happens when I insert minus 1 in for x. X plus 1, the remainder when I divide by x plus 1 is like inserting minus 1 into the original polynomial. And that gives us a very cool shortcut called synthetic division. And you may or may not have seen this before. And if you have seen it before, you can still always practice more. But in the 10, 15 minutes I got left here. No, it's more like 10 minutes, sorry. Let me show you how to do synthetic division, because synthetic division was a way of doing long division much faster than writing all these x's over and over and over again. Let me go to the board, which I don't do too often. I'm a basketball fan, but I also like soccer, so this is my Frankfurt football soccer jersey. I got to go to Frankfurt once in Germany. So let's talk about dividing this by x plus 4. We're writing x squared minus 5x plus 7 divided by x plus 4. I can use the long division, no problem, but it is a lot of writing. I'll show you a quicker way to do this. But, and I'm not going to do the division for you, but if I multiply by x, I get x squared plus 4x, subtract minus 9x, multiply by minus 9, negative 9x minus 36, subtract 43. Subtract, subtract, always subtract. So the answer is x squared minus 5x plus 47 divided by x plus 4 is equal to x minus 9 plus 43 upon division by x plus 4. 43 is the remainder. I write that up here, just in case we have to erase. Synthetic division is based on this idea of plugging in the number. Here I'm plugging in the number minus 4. In a sense, I'm plugging in the number minus 4. If I multiply both sides by x plus 4, then plug in minus 4, part of this right side will go away and I'll just be left with a 43. If I put minus 4 into here, do I really get 43? Negative 4 squared is 16. Negative 5 times negative 4 is 20. Now I'm up to 36. 36 plus 7 is 43. Dividing by x plus 4, the remainder gives me the same thing as if I insert minus 4. So watch this. Let's take the minus 4. And I'll use a little division bar here. Some people write it differently. But I'm going to write down x squared minus 5x plus 7. But I'm not going to write the x. I'm not going to write the x. I'll just write 1x squared minus 5x plus 7. I'm just writing down the three numbers, 1, minus 5, 7, the coefficients. That's why I said the word coefficient to you. And now, let's play this game where I will add the columns and multiply by minus 4. each time. So what I do is starting off, 1 plus nothing is 1, minus 4 times 1 is minus 4. This time I'm going to add minus 5 plus minus 4 is negative 9. Minus 4 times minus 9 is 36. 7 plus 36 is 43. Now look at those numbers, 1 minus 9 and 43. Minus 43 is the remainder. But the 1 and the minus 9 are meaningful too. The 1 and the minus 9 were the coefficients of the answer. So in a funny way, I just did x squared minus 5x plus 7 divided by x plus 4. I thought of x plus 4 as inserting minus 4. And this short version of dividing, it's called synthetic division, gave me the remainder and the answer. X minus 9 plus 43 over x plus 4. Now, some people don't like to think about adding here when they did subtracting here. That bothers them, and I understand why. So if you like me to say it in another way, I don't mind to do synthetic division with subtraction. And in fact, that's the way I would learn to do it. And I'm used to doing it with subtraction because I always think division is subtracting. So if I was to do it with subtraction, let's write it like this. Same 1, 5, negative, and 7. Same coefficients. But instead of writing the opposite of that number, I'll just write straight 4 right here. And this time I'm going to subtract, multiply, subtract, multiply, subtract. So it's 1 minus nothing is 1. 4 times 1 is 4. Negative 5 minus 4 is subtract. 4 times minus 9 is negative 36. And 7 minus negative 36 is 43. Same result, but here I was using subtraction. I don't mind which way you use it, but this gives you 2 big wins. It tells you the result of the dividing. X squared minus 5x plus 7 divided by x plus 4 is x minus 9 plus 43 over x plus 4. If you want to do it with addition, that's fine. You just have to change this sign to 4 to minus 4, and you have to add. But it also gives me a really quick way to insert a number into a polynomial. Let me do one more example like this. Synthetic division is something you have to practice. He makes you practice it a lot in this section 4.2. And he does use the addition method. So if you want, I'll do it the way he does it. I use the addition method, no problem. Let's say that I want you to evaluate something. And let's pick, we eliminate the subtraction method. Let's pick one of the crazier evaluations I did at the beginning. Oh, one of the longer ones. Not that one, not that one. evaluating. Right. Let's evaluate 3x cubed minus 2x squared plus x minus 7 at x equals -2. That was in the notes at the near the beginning of class. I can use synthetic division to stick this -2 in here very fast. Watch. -2 right here. Write down all these coefficients in order, must be in order. And in fact, if one of them is missing, you have to put a 0 in that column. But I have 3x cubes minus 2x squareds plus 1x minus 7. I don't write plus signs for plus 3x squared and plus 1x. Now let's use the book method, and that is add, multiply, add, multiply, add, multiply. And if you get good at this, you actually do it pretty fast after a while. It's kind of fun. 3 minus 6 minus 8, 16, 17 minus 34. And 7 negative plus -34 is -41. I don't know if I'm holding this up in front of the camera nicely or not. But that's the -41 that I got when I inserted the -2 in earlier in the beginning of class. But you see all that work we did? I mean, it's not wrong. Of course it's right. But that was a lot of paying attention. Minus signs and everything. Synthetic division, let me insert that number in almost instantly. 3 minus 6, -8, 16, 17 minus 34, -41. I can insert that number very fast. It's kind of fun to practice though. Okay, this is a consequence of synthetic division. In other words, if I said, what's 3x cubed minus 2x squared plus x minus 7, let's write it as a division problem, divided by x plus 2, and I switch that number from +2 to -2 to do that, to insert the -2. Let's do the polynomial long division. Forget it. I don't want to write that much. Here's the answer. 3x squared. If you take x cubed divided by an x, you're going to start with 3x squared minus 8x plus 17. Now with a remainder of -41 upon division by x plus 2. Sorry, I'm in a hurry, so I'm being sloppy. With a remainder of -41 upon division by x plus 2. So synthetic division serves two purposes. Really fast way to divide. Really fast way to insert a value and evaluate. Okay. Now that's pretty good for today. I still want to, remember we don't have a session on Thursday. I still want you to go and read the section 4.3 by yourself. And that section is called factoring out greatest common factors. That's not too messy. You can manage that section by yourself. You can, I'll post these notes, I'll post this video. You can send me a question by email and I'll get back to you later. You have homework due tomorrow night, so just normal schedule. And then I'll see you again 1 week from today. So you guys go outside, have a good day. Cool, but at least the sun's out.